Good evening and welcome to Monochemistry. Tonight we're going to speak a little bit about writing ionic formulas. And basically, the most important thing you have to remember about these formula is that a chemical compound, an ionic compound, has a net charge of 0. Overall, the charge of the compound should be 0 unless otherwise stated. So, how do you figure that out? Well, you get your elements, your ions for that matter in this case because they have charges. You have your sodium ion here. Notice it has a positive. This would be the metal. And you have your non-metal ion. This is the chloride ion here, which is a negative charge. So the question is, how do we add these two together? In what combination, in what format can we add these together such that the total compound equals a 0 charge? Well, I've got a 1 plus and a 1 negative. If I add those two together as they are, I think you'll agree there's no charge. So the chemical compound for this one would be NaCl, because the positive of this and the negative of this cancel each other out, giving you a compound, sodium chloride, NaCl. Take a look at this one now, and I think you'll see this one's a little bit different. In this case, we have the metal ion here, the positive charge, but this time it's a 2 positive charge. And over here we have the same negative anion that we had before, the non-metal, the negative ion here. And I think you'll see that if we were just to add these two together, we would not end up, in fact, with a 0 charge in this case. So what do we do? Well, we're a little stuck here, but that's okay. There's really only a couple things I can do. I can either add more of these or more of these. Now, since this is a bigger number, a 2, and this is a smaller number, a 1, it would make sense to me to add more of these. This is a 1, this is a 2, so if I add another one of these, I think you'll agree now that I have a 2 positive and 2 negatives. What's the chemical formula? Well, how many magnesiums do I have? I have 1 Mg. And how many Cl's do I have? Well, I have 2. So MgCl2. So the question was, how many of the smaller number did I need to make it equal to the bigger number? All right. Let's move on to this example. Slightly harder still. All right, so what I've got in this situation is a 3 positive charge on my metal ion and a 2 negative charge on my non-metal. Now, this is the bigger one. This is the smaller one, so let's try the same strategy we did before. So I'll add another one of these. Okay. So I had a 3 plus charge here, and now total over here I have a 4 negative. 2 minus and 2 minus equals a 4 negative. But yet these still aren't the same. This one's now bigger, so okay, well I'll add another one of these. So I've got a 3 plus and a 3 plus. That's a total of 6 plus here. Over here I only have 4 minus, so that doesn't work, so I need to do that. 3 plus and 3 plus is 6 plus, 2 minus, 2 minus, 2 minus. There's a 6 minus there. My 3 plus, that's my 6. 2 minus, 2 minus, 2 minus. So there, now they're balanced out. I've got enough there. So I'll go Al. How many Als do I have? Well, I have 2 of them. And how many O's do I have over here? Well, I have 3. And there's my chemical formula. Now, in essence, what I've done here is I found a common factor between these two numbers. Think about it. What's a common, not a common factor, sorry, common multiple. My math term's getting messed up here. What's a common multiple of 3 and 2? I think everyone will agree that it's 6. Now, watch this. 3 plus and 3 plus is going to equal 6 plus. 2 negative, 2 negative, 2 negative equals 6 negative. Right? So if I have 2 aluminums, that totals a 6 plus charge. If I have 3 oxygens, that totals a 6 negative charge. There's my magic number, my common multiple. There it is. So when writing chemical formulae, you have to keep that stuff in mind. That in a nutshell is how you do this for ionic compounds.